Bismillahirrahmanirrahim. So we are going to start this lecture number 5, which is on data normalization. Basically, normalization is performed after we are done with the relation structure, and the purpose of this data normalization is to validate that the design that we have designed so far that is correct and that is free from anomalies. And if there are any anomalies, so those anomalies are also corrected during this normalization. So the main objective of this process is to validate whatever design has been designed so far. So, as I told you that it's basically a tool to validate and improve the design. And the anomalies which can be there, the main reason of those anomalies can be unnecessary duplication of data. We shall discuss this thing in detail in the coming slides. So it can also be viewed as a process of decomposing larger relations with anomalies in order to have smaller, well-structured relations. So if, for example, we have some relations which have some anomalies that we shall see in the next slide, that what type of anomalies can be there. So for example, if we have some larger relations and there are some anomalies in those relations, so this process is also decomposing, breaking those relations to convert those relations into well-structured relations. And basically a well-structured relation is something that we want to achieve through this. So basically we want to have all of the relations in the relational model as well-structured relations. And as I told you that a well-structured relation is a relation on which any editing operation, which are basically insertion, updation and deletion, which basically cause the change of the contents or data of the database. So all of those operations, they can be performed with minimal data redundancy and without causing any inconsistency. So if we are able to apply all of these operations without causing any inconsistency on a relation, so that relation would be a well-structured relation. Otherwise, if we are not able to apply these operations on a relation, and for example there is a threat to consistency while we perform these operations, then it would mean that the relation is not a well-structured relation. Rather, that relation has anomalies. And related to these three types of operations, we can have three types of anomalies in a relation. The first type of anomaly that can be there is the insertion anomaly. This anomaly basically is that, for example, if we want to add some data in a relation, and for example, we are forced to add some duplicate data, okay, that we do not want to add, so it would mean that there is insertion anomaly in that particular relation. Okay, so I repeat that, for example, we want to add some data into a relation, and if we are forced to duplicate some data that we do not want to duplicate, so it would mean that there is insertion anomaly in that particular relation. Similarly, if we want to delete some data from a relation and we are forced to delete some data that may be required in future, if that is the case, then it would mean that there is deletion anomaly in that particular relation. Okay, so for example, we want to delete some data, and with deletion of that data, we are also deleting some data that may be required in future that we do not want to delete. So that would be a deletion anomaly. And finally, we have modification anomaly, which basically is related to the update or the editing operation, which is basically we want to change the existing contents. For example, there are some rows, there is a row or some rows, and we want to change the values of a cell or some of the cells in those rows. So that operation basically is a modification operation. And modification anomaly is that we want to change something, but because the data is duplicated, so we need to make that change to different places. Okay, for example, ideally one object should be having one representation, but for example there are multiple representations of an object, and for example we want to change value of a field in that particular representation of an object, but because that object has multiple representations, so we are forced to make that change to multiple places. So it would mean that there is modification anomaly in that particular relation. So a general rule of thumb is that one table, that one relation should pertain to one entity type. So for example, if by mistake we have merged more than one entity types in one relation, then it would mean that that relation would be having these anomalies. So if you want to have a free anomaly free relation, then this general rule of thumb should be followed, and this is that you should be having one entity type per relation. So similarly, while you are designing the database at conceptual level, if you merge multiple groups into one entity type, then again that would be converted into the relational structure, and you'll be having more than one entity types in a relation. Or during the conversion of ERD into the relational structure, if you convert during that conversion, if you convert and if you merge more than one entity types into one relation, then again you will be facing these anomalies. So your well-structured relations are the relations which are free from all of these three anomalies. So here is an example. If you see in this example, apparently it seems that data from multiple themes has been merged. Like we can see some of the columns which are related to employee, for example, name and employee ID and department name and salary. And apparently it seems that these attributes belong to employee, but at the same time we have an attribute course title that apparently seems that it is basically an attribute of another entity type that is course. Maybe that's a course entity type. So it's a clear indication that we have merged more than one entity types in this one relation. So this relation is highly likely that this relation should be having those anomalies. So the first question is that, is it a relation? The answer is yes, it's a relation, because it fulfills all of the checks of a table to be a relation. It has unique column names, it has a unique own name, and order of column and rows is irrelevant, and there is no multi-valued attribute in this particular relation. But let us check this relation against these anomalies. The first anomaly, that is insertion anomaly, that is we want to add some data and we are forced to duplicate some data. For example, I want to add a new employee, and that employee, first thing is that I cannot add an employee unless and until that employee has a course, okay, because this relation has a composite ID primary key which consists of employee ID and the course title. So for example, there is an employee which takes this SPSS course, okay. So for example, there is an employee taking this SPSS course. So I'll add his data over here, but I'll have to duplicate this SPSS thing, okay. So basically I'm duplicating some data, okay. So I'm forced to duplicate this data. It means that insertion anomaly is there in this particular relation. So insertion anomaly is that whenever I want to add a data to a relation, I'm forced to duplicate some of the data. And here you can see that there is this is the case in this particular relation. The second type of anomaly was the deletion anomaly, okay. So deletion anomaly was that I want to delete some data, but some additional data is deleted that may be required in the future. So here in this example, if you see, for example, I am interested in deleting the data of this employee with employee ID 110. For example, I want to delete this employee's data only, but because I'll have to delete the complete rows, and for example, I delete these two rows. The aim was to delete the data of employee only, but the data of these two courses, which is Visual Basic and C++, the data of these two courses is also deleted, okay. So we are forced to delete this data which may be required in future. So this means that deletion anomaly is also there in this particular relation. The third type of anomaly, which is modification anomaly, which is basically whenever we intend to edit some data, we are forced to make those changes on different places because of the duplication. So this case can also be seen over here. For example, I intend to change the name of this employee, which has the employee ID 100. For example, I want to add an S in his name. I'll have to make two changes. Ideally, I should change one value only, but because the data is duplicated, so I need to change the data add in two different rows. So this basically is modification anomaly, that whenever I intend to edit one instance, I'm forced to edit multiple rows because that instance is represented through different multiple rows. So it means that there is modification anomaly. So with the help of these examples, we have just seen that although this relation is a relation, but this relation has all these three anomalies present in it. So we have just discussed all of these anomalies which are there in this table, and we have also discussed the reason, and the reason is that because we have merged different entity types in this particular relation, so these anomalies are there. Now there is another concept of functional dependencies and keys, and we are moving towards the normalization thing. This normalization basically is done in different stages, and with each and every stage there is a form associated. Okay, so that form is basically the form of that relational structure. So whenever we move the structure through stages, we achieve those forms. Normally we carry out this normalization at 3 different stages, and associated with these 3 stages there are 3 forms which are achieved. So we have first, second and third normal form associated with these stages. The first normal form is achieved if all of the relations in the structure, if they are relations. It means that for example in the relation, all of the tables that have been achieved by converting the entities and the relationships from the enhanced entity relationship diagram, if all of those tables, if they fulfill the attributes of a table to be a relation, so it would mean that that design is already in first normal form, because there is just one requirement for the structure to be in first normal form, and that is that all of the tables, they should be relations. Okay, so if there is no multi-valued attribute, if all other attributes are there, all other quality checks are there, so it would mean that the structure is already in the first normal form. For second normal form, there are 2 requirements. First requirement is first normal form, and second requirement is there should be no partial dependency. Okay, so we shall discuss this partial dependency in detail. And for third normal form, again there are 2 requirements. The first requirement is that the structure should be in second normal form, so that is a prerequisite, plus there should be no transitive dependency. So we shall also discuss this concept of transitive dependency in detail. So starting off with the functional dependencies, because we have to understand the partial dependency because that is used in the second normal form. So we need to learn this concept of functional dependency. So it's a pretty simple concept. Functional dependency basically is the dependency of any non-key or non-identifier attribute on the identifier attribute. Okay, that is, we said that all of the identifiers, they have the capability, they have the ability of determine the value of any non-identifier attribute. It means that determine means that whenever you query on the value of an identifier, you get exactly one or no result. Okay, which also means that you are able to uniquely identify an instance or value of any attribute of an instance with the help of the value of an identifier. It means that all of those non-identifier attributes, they are functionally dependent on the identifier attributes. So this is functional dependency. There is another concept of fully functional dependency. Fully functional dependency is there when there is a composite primary key. Okay, for example, there is a composite primary key, and by analyzing data samples, we analyzed that there are some attributes which are whose values can be determined by just a part of composite primary key. Okay, so their values are not fully dependent on complete composite key, rather just a part of the composite key can determine their value. It would mean that those attributes are not fully functionally dependent on the composite primary key, rather they have partial dependency. They are partially dependent on the composite key. So we shall discuss this concept in detail in the next lecture as well. So thank you very much.